Hello, everyone, and welcome to the Parsons Technical Webinar Series. I'll be your host today, Jessica Bennett. We have with us today Yoav Rappaport, Parker Wills, and Rob Cushing presenting on leveraging advanced digital solutions for efficient soil remediation in public right-of-ways. If we can go to the next slide, we'll go over a few housekeeping items first. We will keep all phone lines muted until the Q&A session at the end of the webinar. If you have any questions throughout the webinar, you can either submit them in writing using the Q&A feature in Teams, or you can hold it until the end and ask it live by raising your hand. This webinar has been approved for 1 professional development hour or PDH credit. If you would like to receive a PDH certificate, a link to the attendance form has been posted in the Q&A section, as well as the chat. There are 3 multiple choice questions you will need to answer, so please take a look at those. And if you have any issues downloading that form, please let us know and send us an email. And we'll be issuing PDH certificates over the next week after you submit them. And finally, this technical webinar is being recorded and will be posted on our YouTube channel in the coming days. So just a high-level agenda, we'll introduce our guest speakers first, followed by a core value moment before getting into the presentation itself, and then we will wrap up at the end with the Q&A session. And with that, I will hand it off to Yoav for the introductions.
Thank you, Jessica, and thank you, Jessica and Christy and everybody else at the Parsons desk that's helping organize these events that we've had over the last, I think, almost decade or so, but maybe a little less. I've participated in some in the past, and it's a real pleasure to be here and hear the feedback from you at the end or afterwards. My name is Yoav Rappaport. I'm a spatial data integration lead with Parsons X. That's a small group within Parsons, a larger company that's kind of an innovation hub for Parsons. We manage a number of tools and have a couple of products. And over the past 25 years, I've had experience in leading geospatial product development and projects related to environmental. And with me is Parker Wills. He's a senior environmental specialist. And over the past 10 years, we've been using these digital forms. He's been doing a lot of environmental remediation projects and bringing these digital forms, customizing them for our use. And finally, Rob Cushing will close out. He's a technical specialist with over 20 years experience in geographic information system and not just data management, but also remote sensing and utilities. And he really is really a great contributor to our core capabilities and skill matrix. Our core values here of safety, quality, integrity, innovation, and sustainability are really the bedrock of the Parsons way and how we imagine next. So we really like to focus on these items when we're performing our work. One of these core values is, of course, safety. And safety is critical for us getting home, but it's really how a project gets done and kept on track. And it's really all part of being safe, staying on schedule, and cost saving. So it's a system that we embrace, and in many of our projects, and especially ones that have digital forms, we'll have a digital forms dedicated to safety meeting that we have every morning. That way we can have a continuous improvement culture where ideas are brought up, how we can improve safety, as well as making everybody aware of new and changes in the field. And it's because really this particular form solution is bi-directional. So we're able to push out a new alert or things that we've learned from the previous day or things that have changed, such as weather or equipment that's going to come in onto the job site, even to a specific job site. And we've used that. That really brings in our employee engagement, which is really critical. Everybody has a say, everybody can stop work. And that's how these forms are collected and stored in our database. But today we'd like to introduce to you a method that we've used over the last decade at least, and I'm aware of at least 4 or 5 major projects that we've employed this type of scenario for remediation in general and soil remediation specifically. Now, what we're presenting today is as a project scenario for you of solar remediation that really is a culmination of several confidential clients' work that we've done over the last decade, as I mentioned. Once these digital capabilities have matured to a degree, they still need a level of integration between them. So here we're calling this the Acme Company Solar Remediation Project in a right of way. We've got the Acme headed by Wile E. Coyote, and which operated they operated a site for it's a waste incinerator that operated in the late 1940s here. And the Roadrunner Agency is our client, is charged to overseeing this environmental remediation. And our scope really is to perform the work of soil sampling, planning, the excavation, possible disposal, restoration, and of course, reporting. But we always have to keep in mind both, the safety aspect and minimum disruption to the community. So these tools are being used for that purpose to have our work done accurately, correctly, repeatedly, and prevent disruption to the community. So I'm going to set up how this basic project is organized here. We've got these right-of-way common areas, which we call the RDU, the Remedial Decision Unit. It's inside a street segment. But the complications, of course, is to know how deep you need to excavate. And even if you were told to excavate to a certain depth, you've got a number of obstacles in your way, such as trees, tree trunks, roots, electrical poles, underground utilities. Um, and so those may prevent you from reaching optimal depth. And so we want to be able to accurately report that. At the same time, we're looking for opportunities to prevent disruption to the community, and that is because we're exposing soil and that which has some kind of analyte, probably lead. That's why we're cleaning it up, and we don't want that to become airborne again. And so we have a number of air quality monitoring, and that's another kind of aspects of the data management of it. We may also have a school zone, or we're taking up valuable parking spots, possibly, or bike lanes on the street. So we want to minimize that. We want to get in there, and get out of there as quick as we can. So again, our management of this project is really centered around these remedial decision units. We'll just use RDU. And here is a kind of a scenario of a street segment between two major streets, or however we broke it, and the remedial units. And sometimes these remedial units you might end up discovering them, an extra one, or needing to subdivide them, as we'll show in later in the presentation. But all of that has to be documented so that we can follow that and we can communicate between us. The basic scenario, and this is kind of the architecture, or really the, the digital solutions at play that interact together to allow us to complete this project properly, is really our laboratory information system, the Equus, our data collection system for the field, which we've selected Forms on Fire. We've had a good experience with them, and the Esri GIS enterprise system. And of course, it's all being fed and managed through the Office 365 SharePoint, along with a SQL and MS Microsoft Access even being used to move some of that data that's not fully automated. So we're making all the decisions on the objective of the project. So what level of contamination is acceptable, if any, the laboratory data, and we're reaching stage gates or decision points of how deep to go, or if we should continue cleanup. So those are the two stage gates there. They're governed by data. Data will tell us where to go. How these decision units gets subdivided is really about the soil volume and how long we want to keep these open areas. So we want to keep them small. That will prevent, really the pollution in terms of airborne pollution. And then we want to think through each project is always a little bit different. It's got different reporting needs or subdivision of the areas. So we want to really think through the digital form development and how we deploy them. But and as Parker will show you, it's not one deployment. He often ends up with multiple versions of the same forms or multiple forms to achieve it. And then we're using the GIS enterprise platform for both data creation, digitization, reporting for both the document packages and for tabular data analytics and project tracking, web map project tracking, so you can see where we are and where we're heading for logistical purposes. Now, why is it all important? And really, we're really excited about the way that these tools work together because we've come across several types of projects that are very similar, whether it's soil remediation or if it's groundwater remediation, often projects that have a field data component to them. It's really valuable time, it's dangerous time. And so we want to streamline those field operations as much as we can. We want to have the operators in the field performing their day performing their day-to-day um, task accurately, recording back to us, and also efficiently, especially when it comes to taking locations and photos and having those photos organized. You don't want the field personnel to be typing too much there, as well as the maps. This is a particular challenge in these kind of like high fidelity and a lot of information that needs to be transformed, how those maps get marked up and digitized so that data can be used. So we've got this verification process in terms of the data accuracy. We have the section of field operations, and we have the bidirectional movement of data between the field and the office. And finally, we've got that data being used for multiple stakeholders here, whether it's for the laboratory information system, different forms and we submitted to agencies. Of course, the reports, tabular data, and data analytics. All these aspects of the forms and the templates are all there to be able to proactively engage with our client and to anticipate any kind of issues or just see that everything is running on schedule and on time, all for the purpose of really minimizing the impact on the surrounding community. I'm going to turn it over to Parker. He's going to kind of walk you through how he thinks through the development of a digital field data collection system. Go ahead, Parker.
All right, thank you, Yoav. Hi, this is Parker. I'm talking about Forms on Fire today. It's a software as a service company. And basically what Forms on Fire allows us to do is you have a suite of forms that's available on your smart device. So that could include your iPad or your iPhone. It works with Google, it works with Samsung. And you're able to basically collect data in real time out in the field, click a submit button, and then that data is moved within seconds to your local server, can get pushed up into the cloud. Uh, I'll talk later about how it integrates with SharePoint. Um, and we're in the 21st century. Data's basically never been more important, and our client is asking for more data than ever. And Forms on Fire really meets those needs. So we're scaling past, the 11.5 by 8 piece of paper with pen, and now we've moved to the digital age. There is no limitations on your phone or your iPad with how much data you can collect. Other great features about Forms on Fire is you're able to propagate that data to multiple locations. So With the click of a button, you can send off emails. So specific data entered in your form could go to specific personnel that need that information to make specific decisions. You can upload a finalized report template to a document library. And then you could also upload specific data that would fill in on SharePoint lists or in your SQL Server database that you could query upon. Um, Other great features of Forms on Fire is quality assurance, quality control. So you can really clamp down on human error. It's a single entry point. So before you would be transcribing this data on a piece of paper that would go in a binder. Oftentimes it's chicken scratch, there's smudges, things get ripped out of three-hole binders. Then you have fat thumbs, when you're typing it into your Excel spreadsheet. This cuts all that human error that could uh, these failure points. It's a single point of entry. So you have one piece of data entered on the front end that immediately travels to the back end and can go into finalized reporting. Um, Forms on Fire is basically your front end part of the data management ecosystem, and it integrates with other software applications for backend. I mentioned SQL. I'll get to other applications that we use Forms on Fire with, but that basically meets all your database management needs. So from processing to storage. And ultimately, what Forms on Fire does is it drives efficiency. So you're speeding up your time, your delivery of data, and you're also meeting the new larger scale of what data is required for your projects. All right, so currently Parsons has 16 active environments. Usually these are client-based. Some, if the project is very large, will have it dedicated to a large-scale project, but in most cases it's by client. And within those environments, we have site-specific folders. So in the case of like our mock Acme project, we're focused on the Salt Lake City project site. However, Acme might also have a Tucson site. And so you would have the Tucson folders and the Salt Lake City folder where a suite of forms would be housed in each. And you could limit access for your field team to those specific folders. So when they log in on their smart device, the Salt Lake City field team will only see their suite of forms that's applicable to the Salt Lake City project site. There's also benefits to running test forms. So when you're starting out, maybe you want to put it in test. Maybe you want to limit it just to your field team lead to get feedback. You don't want to roll it out to all field members. And so you can kind of go through it, nail down the details, get it finalized, and then finally publish. And then it can get rolled out to everybody who needs access to those forms. Forms on Fire also charges a reasonable cost per account user on a monthly basis. All right, so what are its use cases? Well, currently Parsons has been using Forms on Fire for over 10 years now. It's primarily been in the environmental sector, so for remediation and monitoring primarily, but Parsons does a plethora of work, including in the energy sector and transportation, industrial and mining. So like these forms are ubiquitous, they can be applied anywhere. Um, but basically, what we've created over these 10 years primarily are examples like site facility inspection forms, inventory and audit forms, operations and maintenance inspections, sampling and gauging, safety forms, tailgates, AHAs. It utilizes GIS data collection, and we can integrate mapping documents. And then as Yoav had mentioned earlier, there's two-way data transfer. So there's data sources you can build out, whether that's importing through an Excel spreadsheet or a SharePoint list, and those feed your form. So you can have real-time updates from the office if needed. and you can force sync those to the forms immediately through your cellular service or through a Wi-Fi connection. Currently, we have 230 unique users using the forms per month right now. We've deployed Forms on Fire over 50 projects in the US and Canada primarily, and we've submitted over 350,000 forms over the course of our decade working with them. All right, so key features. I mean, the key features of Forms of Fire really is like you have this data collection device that's right in the palm of your hands. It's very convenient. Um, it's able to collect data in all kinds of formats. Before you were just writing everything down. Now you can collect data from photos, from video, from audio, text, and numeric values. So depending on what kind of information you'd like to convey, you can select on that kind of format. It also has all kinds of quality assurance, quality controls built in. So instant warnings, you can highlight specific fields that maybe members need to be aware of. You can make those fields required. You can do data validation, so you can limit ranges on your fields. So if it needs, let's say, a pH value that's from 0 to 12, you can upload from data sources like historic values. So for like a well, if you're gauging, you can have historic groundwater levels. And then if they enter in a current value and it's a standard deviation off, that might raise a flag within those fields. So that works with hidden calculation fields that can be working in the background. There's also like workflows and tasks you can create. So if you submit, you could submit to a reviewer who would go over your work and maybe add comments and make changes and kick it back to the submitter who would, make updates as needed and then could send it back for finalization. There's metadata that's collected in these forms. So we have like who submitted it, when they submitted it, date and time, and location. You can capture your coordinates within a 15-foot radius. You can also tailor reports. So the data you enter in the form, you can kick out PDF report templates or Word documents and even Excel spreadsheets. And you're also able to print out unique sample labels. So you could create specific sample IDs that gets sent to a server that a printer is set up on, and then that would print out your sample labels. Okay, so form development. This is really great too. Forms on Fire has a really nice user interface. We find that they're above and beyond the peer group that they are competing against. It's got a lot of adaptability, a lot of flexibility. Even for beginners, it's very intuitive, so it's not intimidating. You can just get started. We'd love to have you. Um, I'm a creative person, so I've really enjoyed using this software to meet clients' needs. But if you're feeling a little intimidated, there's all kinds of other ways to get your forms started. So like Forms on Fire has a catalog of all kinds of Forms on Fire templates. It even has features like where you can convert a document. If you have like prior reports, you can upload that in and then Forms on Fire will transfer that into an electronic form. Um, Internally, we have several experts with Forms on Fire for Forms on Fire development. I include myself, Jennifer Trim, Brendan Baranek Olmsted, so you can consult with us. And they've rolled out a new feature with AI prompts. So you can prompt your form. You can upload a document and start prompting it with what you want. So it's really cool. And then on top of that, we've produced over 750 forms within Forms on Fire. So if you have a project that's similar to what's been done before, we can clone those forms and then tailor it to your project's needs. All right, these are the connectors. So this is basically where Forms on Fire integrates with other software for your backend needs. I've highlighted what we've primarily used at Parsons, but there is a plethora of other software that it works with, and that list is ever growing. So from data sources that are within SharePoint lists or Excel You can import from Excel. We've operated with ArcGIS, emails where you're able to add attachments, or you can even get that data to go into the body of your email. SharePoint document libraries and lists, SQL Server databases, and even Microsoft Power BI. All right, so this is the data source we use for the Acme project. Highlighted in red is, you'll see in the later demonstration, how data gets filtered into the form. You're able to, so basically we can make updates in real time. So for instance, if your project's growing, or in the case of, we found often with RDUs, maybe there's been a change out in the field. We could have a field team member say, hey, we need, SL 3603A. There's been a split. We need that right now. I can go into the data source on my laptop, make an update, force sync that to Forms on Fire, and then the field team within minutes will see that new data in their form. All right, so I want to show you guys a little demonstration of what we've done with the Acme project. This is going to involve our daily construction form, how our block street segment RDU data source feeds that form, and then how we're pulling in Rob's GIS excavation maps to make further edits and annotations to those maps within the form, and then how that data ultimately gets spit out to our SharePoint documents and lists. All right, so what you can see here right now is these pick list options being pre-selected. They're filtered based off the data source that I'm selecting here. I'm selecting my user, Wiley Coyote, help. We're not doing, for expediency, we're not doing a lot of different parts of the form. So no pre-excavation. We're doing excavation for our first day of construction. And usually on our intro of our Forms on Fire, we do a lot of site conditions. Some fields are not required, so you can skip if not necessary. I'm not going to be taking any noise measurements today, so you can see tabs start to go away. This is also a nice feature, so we can go through here and you see I start deselecting pages within the form, and we're limiting down to just our depth verification and upload pages. So here's a table. We're going to open up this table and we're going to select our RDU. And here you can see we're going to write in a location description within our RDU. We're going to say we got to 6 inches. We didn't get to our full 18 inches. And we're going to list a reason why. Tree roots. We didn't collect a sample today. Typically we would, but I'm just for expediency. And now we're going to choose some photos. Now on your phone, you would be selecting from your photo library, but this is done over the computer. All right, so you can see in the photo, we've got a watermark. We've got 1.1, that's for our row. And for our first photo taken, you can see a date and timestamp included. And now we're just writing in a little description of what's being captured here. And we're going to take a second photo, include that as well. And now we've got 1.2, so our 6-inch data information, our second photo with that information, and a little caption. All right, so we're backing out. We've got our 2 rows there, and we've got our 1 row. So that was a table within a table. You can see no sample ID was collected, so that's blank in that column before. All right, and now we're marking it's not our last day construction, so we're not completing any of our activities. We're not doing any restoration today, but we do need to clean up before we leave. So we're gonna mark down these notes. We're reporting a deviation. School was let out early. So they were let out at noon and we had to shut down. And this is due to exposure of contaminants, no health or safety issues to report, and we excavated 3.2 tons of soil. All right, now we're going to get to our markup maps. We're going to pull in some of Rob's lovely GIS, and we're going to make some annotations. So where we excavated, we're going to place a little marker on the RDU, and we're going to add our note, 6 inches and the date. And it's nice and legible. So we can back out here. We'll sign off on our work and add a name in case that signature is not legible. And you can see where we've clicked submit now. And we're going to refresh the page here. And you can see this is wound up in our SharePoint list. So here's your map ready to go. That's within seconds. And here's our other location. This is showcasing the photos that we took earlier. So this has got all our information within the list, and it's got our photos captured. All right, that's it for me. I'm going to pass it off to Rob to further discuss geographic information systems for this project.
Awesome. Thanks, Parker. Really appreciate that. Hey, everyone, I'm Rob Cushing. So I'm going to review over the GIS mapping and visualization section of the project. So as Yoav had mentioned earlier, we're utilizing a GIS enterprise system, and we've got several advantages of why we use that. And number one is we have a centralized data management. So all the spatial and attribute data, it's stored in this centralized enterprise geodatabase, whether it's SQL Server or Oracle, for example. And it also reduces any type of data duplication and inconsistencies. Another advantage is multi-user collaboration. This will allow multiple users to work on the same data set simultaneously. And also it allows versioning, which tracks any kind of edits and conflicts that might be encountered from two different analysts maybe working on two different street segments. Data layers, we've got excavation polygons, we've got utility lines, we've got soil samples, and we've got restoration are stored as feature classes. So these are individual feature classes for each one of these data types, and which is great and beneficial because when we need to go and attribute them with metadata, we might have an excavation depth field for our excavation polygon, and then a restoration type for our restoration type as well, and then sampling details for the soil samples. So we can modify those attributes. Data security, also important. So it allows a role-based access, which ensures only authorized users can view and edit data. So you can have, such as Parsons, we're a large organization, you can have hundreds of people in our enterprise system, but maybe only 15 people relevant to the project need access to that data. So you can set those restrictions and into varying groups, and then also assign roles to people where maybe a project manager doesn't need to edit data, where they can view the data and analysts can actually edit the data. Also provides regular backups and protects against any kind of data loss. And also integration with ArcGIS Pro and other systems. So the data is accessed and edited directly from the enterprise geodatabase via ArcGIS Pro. So we can have ArcGIS Pro templates set up that we can then make global changes to, distribute those out to different analysts, and always have those data connectivities integrated right there within Pro. And it also seamlessly integrates with other kind of field data collection apps such as Survey 123 and Field Maps. So I'm going to do a brief overview here of the as-built digitization process. So the purpose here, we want to efficiently digitize and manage our excavation and restoration data for our RDU areas. So our tools that we're using, ArcGIS Pro, that's going to be our main software that we're going to be using for attributing and editing. Enterprise, which we were just discussing, which is our main data management, where everything's going to be stored. We also have a street segment tracker. So this is a Excel sheet stored on SharePoint that is utilized for tracking when certain street segments have been completed and are scheduled to start. We also have a sampling tracker, another Excel sheet that's a running list of all of our soil samples that are collected throughout the entire project. And our daily construction images, and these are really important for verifying where excavation was completed, and it's great for referencing and getting eyes on the ground of those excavation areas to see exactly how it looks and how we need to digitize it. So the end goal, we want to create accurate and up-to-date GIS layers for all of this excavation and restoration areas, and also digitize any utility lines and the soil samples as well that were collected. So digitizing the markups. So as Parker was reviewing, we have markups that are annotated out in the field. So the field crews, we have these pre-made maps, and the field crews are working with these to designate areas for excavation and remediation. And they're manually annotated to record exactly where those depths were achieved for each section. And the target depths, they can range from 12 to 18, which is determined according to our initial soil sample contamination levels. So here's a brief overview of the workflow that we use for digitizing our RDUs. So first, we want to locate our field markup segment, street segments on SharePoint. So that's that location that Parker was showing in his demonstration video. We go there, we find our markup that was uploaded through Forms on Fire. Then we start editing our polygons. So we want to start splitting our polygons based on where those delineations were, where depths were changed from one to the other. And then we want to update our attributes for each one of those segments. So we have our depth status, our as-built depth, what was actually achieved in the field, a depth confirmation, did it actually achieve the required depth that we were going for, and then also the restoration type, whether it's sod, hydroseed, gravel, or some other type of material. Then we're going to digitize our soil samples, which are also annotated on the markup. Those are going to be marked showing where the approximate locations are. And then we have a naming convention that we're going to follow, such as the street, RDU, and then depth. And then we also have attributes for those point features that we want to attribute as well and have that stored. Then finally, we want to digitize our utilities and any kind of obstructions that we encountered out in the field that obstructed us from actually achieving our target depth, whether that was an underground utility or some type of surface obstruction like a tree or a utility pole. So we're going to go through a quick demonstration video here showing how our workflow goes. So you can see we're first referencing our markup for this first PDU, and it was marked at 12 inches without any type of obstructions. And then we also have our markup for the restoration indicating that this RDU was planned to be restored as sod. And we're going to move to our next one. And we're going to mark it complete. Once again, we're referencing our markup, usually on the other screen. And we're going to mark this one as sod as well. Save that. Let's move on to our third. So this one is a little bit more complicated. Looks like we had 2 trees on either side of this RDU that we're going to split this polygon into 3 separate sections and then attribute that accordingly. So we'll get that split showing using our markup, showing where those delineations were. And we'll start attributing this section, mark it complete. So it was only 6 inches. We're going to mark no for depth confirmation because of roots. And this PDU is planned to be restored with hydroseed. So we'll mark that as hydroseed. Move on to our next section. So our middle section did not have any obstructions. Field team was able to achieve 18 inches. We'll mark that yes. You can also see how we have our template set up. We have another additional layer that really helps identify where sections were, where they did meet depth and where they did not meet depth, whether highlighted in green or red. So we're going to move on to our 4th RDU. So we had an obstruction according to the markup on the far right-hand side where it looks like they encountered a water line. So we're going to split our polygon here. And we'll start attributing our larger section, which did reach our target depth of 12 inches. We're going to mark that yes. And we're going to double check our restoration markup. And this one is scheduled for hydroseed. So we'll attribute that and mark this one complete. Looks like it was a 3-inch depth because of that utility line. So we're going to mark no because of utility. Attribute that accordingly. And our final RDU. We didn't have any obstructions on this one, so we'll just attribute this at our target depth, 12 inches. Mark that yes. And our restoration as sod. Save that. And now we'll be ready to save time. I saved the utilities. We can also see how we're digitizing our utilities as well. We got a tree there. We're going to show the markup, kind of do a quick comparison, make sure that we've got everything that's shown on that markup. We have everything digitized in GIS here. So a few key considerations to keep in mind is a couple of challenges that we encounter. Sometimes we can have incomplete or unclear delineations and excavation markups. Sometimes, these are handwritten and marked. So sometimes it can be difficult to read handwriting, or perhaps something wasn't clearly delineated. Sometimes you can have discrepancies between the field photos and markups. Maybe when they were filling out the forms on fire, maybe they picked the wrong image and uploaded that for maybe a neighboring RDU or neighboring section. But great tips for success. Use our daily construction depth verification tables for context. So sometimes for each section, maybe if you're not sure if what they wrote down was a 3 or an 8, you can always verify with our tables on SharePoint that will clearly show what that depth was that was typed in to Forms on Fire. And then also we can collaborate with the field teams when necessary if we have some type of discrepancy that we need to verify. So now do a quick overview of the visualization process. Now that we have everything digitized, we want to create those final figure maps that are going to be used for documentation. And so here's a quick example of our final product here. We want to create these for our figure 1 and figure C1 and a figure C2 showing one figure showing excavation and another one showing restoration. And well, I've got a quick demonstration video here going through that process. So also with our Arc Pro, we've got pre-created layouts that are templates that are going to be made. So that way everything's consistent across the board here. If we have several different analysts that are going to be creating these, everybody's using the same template. So everything's going to be created consistently with each other. Another great thing, we have a map series set up here. It's really beneficial when we have all of our layers and groups set up here. We can run our map series, which will auto query and filter our street segments and zoom into our maps here for easy exporting. So you can see here, we're going to click our sub block or our street segment here. We're going to export that to PDF. And then finally, we're going to create our restoration figure C2 PDF map. So we've got different groups set up for our relevant layers here. So here's our restoration layers. We're going to run our map series, only showing our relevant street segments. And we'll export that to PDF. And then after we get everything exported, it's always good. Want to do a quick QA, QC, make sure everything was exported as we would expect it to. Review each of our PDFs. Make sure everything's legible. There's minimizing any type of mistypes or labels that are overlapping one another. Make sure everything's nice and clean. So final adjustments to our legend. We always like to show relevant features that are shown on the map. So make sure that the legend's reflecting what's visible actually on the map. If that particular street segment did not have, or particular RDU did not have a utility pole that was encountered, we don't want to show that on the legend. Labels also want to make sure they're clear, they're aligned correctly. Sometimes these can get complicated and you can have different labels that are crisscrossing one another or labels on top of one another. So we want to make sure that that's nice and clean. And then we have our features. We are exporting our figures that we were just demonstrating. And then after that, we'll have our SharePoint location for that particular street segment. We'll upload those figures that'll be used for the documentation packages. And that's on my part. Thanks.
Thank you, Rob and Parker. Hopefully that was pretty clear to me. Been involved in this project for a very long time, but we tried to give you a little bit of the in the weeds and some of the larger picture of why we're doing things as we do. We're required to have a conclusion slide, but really I like to see why this matters. Why are we doing what we're doing? Why are these tools are being used together, and how we're bringing this project to fruition. And I guess at the end of the day here, we want to be able to, we're required to produce this package, document taken package, and you've got hundreds and hundreds of street segments. Honestly, they all seem to be the same name, and it's really hard to tell one from the other. So you have to have very good centralized data management, and that data needs to be consistent across the project, from the field to the office to the software that's helping you produce this. And when we have metadata, when Rob finally produces, Rob's group produces those reports, those PDF maps of the final project, They're placed in folders, and we also apply metadata to them inside of SharePoint. That metadata, those tags, help us to automate. Earlier, when I showed that kind of circle of activities, we have the data management side, Office 365, we're using Power Automate. So we've got folks writing, scripting to allow us to automate and kind of bunch, collect all the relevant information, organize it in the right order. And so that way we know that we have a repeatable process every time. We want to be able to repeat that. Of course, it has to be accurate, it's got to be concise, and it's got to, serve the needs of the client and the community. And all of this is really for efficiency. We want to be out of the residents' way. We want to know that we've cleaned it to the right criteria, and we're out of there. And we want to be able to document any obstructions, any hangups, anything that prevent us was in our way, and also to track continuous improvement in the process. And I think Parker brought that very, brought that point to bear, is that the versioning of the forms, you're not going to have one or two versions. You're probably going to have 5 or 6, because you find new things in the field and new one-offs that you want to account for. So he's writing in the logic in behind the scenes. He's putting in the logic to account for this situation and that situation. That way, that data is not being edited manually inside the system. It's getting collected, correctly verified from as much as you can from the get-go. It's not going to be 100%. There's just not. So this is not a canned system. This is a set of tools that we've used over the last decade or so that seem to work well together with each other. And we've learned, the pinch points and what areas we need to hop things over the wall, as we say. So I really appreciate the time you've taken to talk to us, engage with us, and we're open to questions once we let you know. We're open for questions, and then I think we'll have final words in the next 8 minutes.
Yeah, thank you guys. Appreciate the great presentation on how to really modernize data collection and improve a lot of quality and efficiency. If there's any questions, you can either raise your hand and ask it live, or you can enter it into the Q&A section.
Yeah, I don't see any questions right now.
Looks like Leslie posted a question in the chat.
Okay. Okay, Leslie pointed out, how were remedial decision units defined and what criteria? So we're looking for these small areas of exposure. So we want to make sure that we've hit some kind of threshold volume. Every project has its own volume, its own risk matrix, or how long these are exposed. So they're chosen because they're along that street segment. We're going to close that parking. We're going to alert the residents and let them know that we're going to be working there for that week or several days, and we're going to be in and out. And also we are, they've been obviously selected because of their priority, because of the data that initially led to this investigation. And the data is driving really how long we're going to be there, because it's about the depth, and then the obstructions will also come into factor. Okay.
Looks like we got another question from Carolyn Hillman. What measures did the project take to minimize disruptions to the community during remediation?
Okay, that's kind of as well coming along with choosing of the RDUs. So air quality monitoring is one of those that we monitor, so that it doesn't cause disruption and people have to stay in their homes. Or I don't know what I don't exactly know what the what the results is, but we've got to close up the site. And does that answer it? As well as always, we looked at the school zone. So the GIS map is looking at the school zones. It's looking at the proximity of those schools. That's one aspect I know that came to bear on several of our projects in the past.
Okay, we have another question from Ann Way. Great presentation. I realize you only had so much time today, but can you expand briefly on how you integrated your chemical data from Equus into your geospatial drawings? Do you employ a REST API or anything different?
That maybe Rob can take it. But I covered it a little bit. Rob, if you want to add a little bit more afterwards, but um, we're receiving EDDs from the lab that are compliant with the Equus system. And so we're pushing the data in two ways into the Equus system itself. Uh, the EDD, the Equus data, we don't need any analysis on it. It's already been analyzed and verified. And then we're pushing it to our on-prem SQL database, which then the GIS platform can read as a tabular data in a kind of one-to-many relationship. So we've got a sampling site, and then we have either multiple depth for that site, and that's being used in the labeling.
Yeah, that's exactly right. If I can follow up. Yeah. And then on our GIS side, we'll have those point locations displayed on the map so we can see those results. Usually our RDUs are already going to be determined beforehand, if they're going to need excavation or not. But we also have that data in GIS so we can see those points and those results in GIS as well.
But Anne, I really like to see that kind of bi-directional movement, or not bi-directional, but like read only from the Equus store into a system. But in our example, we didn't use that.
So we have another question. Can Forms on Fire arrange the sampling ID alphabetically, as it would be easier to review which locations have been sampled?
Yeah, you can set up a way of organizing samples, wells, any kind of list. You can make it alphabetic, or you can order it in any way you'd like.
And also, we've got one more question that came in. How does this system of mobile data collection and forms work in remote areas like Alaska, where there's no cellular or Wi-Fi service?
So typically what would happen is you probably have a field office with some form of Wi-Fi or LAN connection. And in that case, you'd fill out your form out in the field, but then when you return to the field office, you'd be able to click submit, and then the data would transfer then.
Yeah, the capabilities of disconnected editing in remote or lack of any Wi-Fi or cellular network is part of the capability. So it'll store it. Of course, it doesn't have the bidirectional movement of data. You would want to download your latest form version and any data that you need for the day, and then sync it once you're back. That capability is also available in some of the GIS form solutions. So we're, this Forms on Fire solution has very ability for very intricate logic. And so that's why it's being used, because of its intricate logic and ability to quickly manipulate it.
All right, well, I think with that, we'll wrap up Q&A. If anyone else has a question, you can reach out to our presenters directly. Our next webinar will be on November 12th on slurry walls, what we have learned from the last 50 years of implementation and research by Dr. Jeff Evans at the same time, 12:30 to 1:30 p.m. Eastern. A link to the PDH credit attendance form has been posted in the Q&A. If you have any issues getting that form, please let us know. And if you have missed any of those questions or content, a recording of the webinar will be posted on our YouTube channel in the coming days. Thank you to everyone who joined us for today's webinar, and we hope to see you again in November.